Bismillah Rahman Rahim. Assalamu alaikum.
1. Introduction. This document data model requirements describes the details of configuration and design and field level requirements for the data model utilized in the project. The overall goal of the project is to create an electrical distribution system network starting from the grid station till the customer meters. So, to achieve the same deliverables, we are utilizing the SEC company provided existing ESRI file geodatabase data model to capture our electrical utility network, equipment and the linear network for both overhead and underground. We have analyzed the overall scope with respect to the SECUDM, and the detailed data model requirements are described in this document. 2. Data model SECUDM. SEC provided us with the ESRI file geodatabase schema, which is most comprehensive data model for their business, and the same data model is implemented all over the kingdom. As per project requirements, there are some changes required in the data model to adopt all the attributes and the equipment geographical positions as per GIS SEC Western Sector Department requirements. So, we have performed the detailed schema review on the provided SECUDM and the following actions taken care to improve the data model. The schema of the electrical distribution network will be updated within the data set. FDS_distribution. The feature classes participate in the dataset are reviewed along with their attribute relational table feature classes to adopt all the project requirements to represent the geometrical part and the attribute information. The provided FDS_distribution network has all required feature classes as mapped below to adopt the geometrical and attribute information. The highlighted feature class equipment available in our project area, and they are used to capture the network data as per the survey data and the SEC provided inputs sources such as built drawings, SLD, and others accordingly. Below table explains about the feature class mapping for the GIS project. 3. Data capturing methods. MNK followed the below described method data capturing for the pilot, and the same will be followed for the whole project. 3.1 Station. We have used two feature classes FCL_station and FCL_station_area to represent the station and placed internal templates as per the concept of internal template defined by SEC for the whole project. 3.2 Substation. We have used two feature classes FCL_substation and FCL_substation_area to represent the substation and placed internal templates as per the internal template concepts defined by SEC for the whole project. Times room substations internal templates placed inside the 4 points of surveyed and aligned with respect to the SEC provided base map layers such as parcels and road center line where possible. Times wherever 2 points surveyed, we have aligned the template to the line of both the points surveyed. Times substation point are retained at the original location of poles for overhead pole mounted substation. Times substation points placed inside the substation area polygon for room, unit and package substations. Times we have used this type of PMT template substations to match with ground reality and MV cable connected to the transformer. We have used MVO cable to represent the connecting line from MV line to transformer for PMT as per reality. We have kept the substation points and moved the templates to the nearest with all other internal assets to avoid overlap crossing with cables running in the same poles. In few cases there are some overlap between the internal template and the cable conductor running in the same route. We have tried avoiding these overlaps as much possible by using the 0.25 meter offset for the LV connecting lines either as bundled conductor or bare conductor, but still there few overlaps and it is acceptable for SEC. We have removed switchgear area from PMT substations as there is no switchgear area in PMT and the primary terminals connected to MV lines is transformer 3.3 transformers. Transformer secondary rated voltage attributed as 230 and 400 volts as per the reality and domain values in the SECUDM, but the technical specification in the nameplates are having the different values as such as 230 by 132, 231, others. As per SECUDM we have applied the standard voltage level in the attribute table of the transformer. Transformers of PMT substations moved from their original surveyed position as part of internal template concepts of SEC. In common, we have used the available domain values for voltages as per the standards and added 400 volts wherever appropriate into the domains as per the change request shared. Times when the transformer output voltage is mentioned as 400 by 231 in the nameplates, we used domain value as 13.80.4 kV. Times when the transformer output voltage is mentioned as 231 by 133 in the nameplates, we used domain value as 13.80.231 kV. 3.4 switchgear area. We have used the subtype 2314 switchgear. The position of the switchgear maintained as per the ground reality either in the right or in the left side of the substation area coverage, wherever possible. In few locations, we kept the switchgear in the bottom side of the substation area polygon to maintain the as per template consistency. 3.5 distribution box. As instructed by SEC, we have placed the mini-pillar internals within the FCL distribution box area with a point feature as FCL distribution box at the original surveyed location itself to make sure the survey accuracy being maintained throughout the office. Hence there are many distribution box area polygons are overlapping with the parcel layer in the base map. We could not avoid this overlap as per the reality of the base map layers are not captured as per the compound walls, instead they have been captured as per the curb limits of the road's right of way and the visible fence limits of the property. We have attributed the circuit details by using the photographs only, and this may vary when we compare to the number of cables connected in GIS because we have used multiple sources to capture the underground network. 3.6 Extensible and extensible area. We have used FCL_EOAs_ area and FCL_extensible to represent EOAs and relevant attributes, done according to the requirements as per the survey photographs. We have represented each extensible switch as an individual extensible point with all required attributes from the nameplate of that particular extensible all switch. The overall area is represented by EOAs_area polygon to show the grouped information of all switches in the real ground. 3.7 Ring main unit. Ring main unit represented by using the feature classes FCL_RMU and FCL_RMU_area with internal template components created by using switches, busbar and respective attribute details filled in the RMU point. We have majorly used the same kind of attributes collected for switchgears as ring main. Units are the typical switchgears used as standalone equipment in the electrical distribution system. 3.8 Service point and meters. As per Secudum design, our survey team collected single X, Y coordinates from the field for the meter's location and attributed them in data entry. Each meter box considered as one ED service point to represent in the GIS, and all the meters available within a particular meter box will be related to that ED service point number. We have used the surveyed F_number as the unique ID to build with relationship between meter and ED service points. These short _IDs filled in both service point no ED service point are real_EDSP meter to create the relationship. When we have found there are multiple meter boxes in the same location, additional ED service points created by copying the existing surveyed point with 0.25 meter offset to the alongside. As agreed with SEC, we created service point for each meter box to represent the reality, irrespective to their source of supply as per SOS numbers written in the meter boxes. In addition, if we identify any service points do not have the details in the as-built drawings or in the hard copy maps, then we will consider the source of supply written in the meter boxes to connect the cables to their respective manipulars SSCR. We will mention the data source for these underground lines as estimated path. 3.9 OH equipment. Electrical distribution network will have multiple types overhead equipment which are all part of the distribution. We have found few overhead equipment and they captured in their respective feature classes such as FCL_dynamic protective device, FCL_switch and FCL_fuse according to their subtypes. 3.10 Overhead network. Please refer to the Appendix 4 sec_GIS_network_digitization_standards.docx for the standards followed for capturing of overhead electric network lines as per SEC recommendation. We have connected the OH lines by using the surveyed pole points. When there are more than 2 OH lines in the same route, we have used 0.2 meter offset between the conductors captured. When MV and LV conductor runs in the same pole, we have kept the NV conductor at the poles and LV conductor drawn with offset standards. We have found there are few OH lines are crossing parcels when we connect by using the poles surveyed. SEC confirmed this crossing are acceptable. For all type of cables conductor, conductor type, conductor material, size fields are updated as per the standard agreed with end users. Refer to the document Appendix 6. Sec_GIS_standards_conductor size and materials. 3.11 of joints. In LV network, we have used overhead cap wherever the dead-end poles identified from the surveyed photos. We have used T-joints or double branch joints in MV and LV network wherever there is a branch in network with proper photograph evidences. In overhead networks dead ends, we have used respective end cap subtypes when there is no further supply from that particular pole. We did not consider the service cables as continuation of distribution. Wherever the OH network continued from the dead with help of cable risers, we have not used end cap as the distribution network flow not stopped at that particular point. When the LV distribution lines ends at a pole with service connection, we have used end cap too. Close the distribution network and service cable also tapped in the same location. For our service connections, we not used any joint as these are all simple tapping from the main distribution LV network, and we maintained to create a vertex in the distribution line to maintain the connectivity. 3.1 to UG network. We have used SEC provided vector base map as reference to create the UG network with SEC digitization standards. We have followed the shape of GIS parcels data provided by SEC to represent the network route and maintained the offset from the same parcels. We found there are some UG cables are crossing the parcel boundary when the substations distribution boxes are inside the parcel or surveyed service points are inside the parcels. SEC agreed these crossings are acceptable. We have found there are few service connections directly taken from substations instead of from mini pillar or poles. The same connected to LVDB area's internal assets accordingly. As agreed with SEC PMO, wherever the satellite image or base map not provided, we have used the online imagery to complete the UG digitization. We have drawn the reference parcel lines in the feature class underground linear structure. Please refer to Appendix V sec_GIS_UG network_digitization_standards.docx for more details. 3.13 UG joints. We have placed UG joints as per as-built reference, and if there are any major attribute change in the cables. 3.14 cable riser. We have placed all the cable risers with proof of survey photographs only. When we found there some cable risers are not connected with subsequent UG cables, as there is no proper evidences for the connected cables. Therefore, we have kept the cable risers without connecting to UG lines. Times we have used the subtype MV cable riser when there is connection between MVO and MV UG network. Times we have used the subtype LV cable riser when there is LV UG network distribution line connected to the OH distribution line. Times if cable riser is available at dead ends and the OH distribution network continued by UG network, we have used cable risers to join the OH and UG network's electricity flow. 3.15 pole. We have used the subtype OC13S for all MV poles and subtype LTP for all LV poles and used WLTP wherever the distribution cable taken a support from a building wall. We have not surveyed added the WLTP when there is support pipe used for meter box connectivity only due to they are not constructed to distribution purposes. They are just as the support to bring the service cable connection to the meter boxes. When there are LV conductors sharing MV poles, we have used the same subtype OC13 as the poles are mainly to carry the MV network. As per our project, requirements have updated the pole height as 13 meter for all MV poles and 10 meters for LV poles as per the agreement from end user. All PMT substation are located in poles with subtype H, and we found there are some additional H poles without PMT substations. Circuit line considered for MV poles only as per the MV feeders count runs across that particular pole. The reason even there are LV lines available in the MV poles are just as ignored as per SEC guidelines. 3.16 Hyperlink. We have created hyperlinks to the overview photo of that particular electrical asset, and it can roll forward and backward for the rest of the pictures for the same asset. each asset stored in a particular folder structure and segregated the subfolders as per the survey shot ID. Each shot ID folder contain all its relevant photographs with the prefixes such as times OB is equal to overview, times OB is equal to open box, times NP is equal to nameplate. For polls in the pilot, we have created individual folder for each shot ID and renamed the photos as per the internal survey codes LTP, HLTP, HTP, H and the abbreviation are as follows. Times LTP is equal to low tension voltage pole. Times HLTP is equal to high low tension voltage pole, combination of LV and MV circuits. Times HTP is equal to high tension voltage poles, MV poles. We have used the same folders of poles to represent the hyperlinks for cable risers. You can modify the hyperlink base path with your local directory name in the ArcMap MXD document delivered, and it will automatically open the entire hyperlinked asset. As new setup, we have created a single PDF file for every survey photo in that particular location within a specific asset category. These PDF file paths are copied in the field hyperlink field and the link for photographs are kept in pic_1 field. 3.17 Geometry Network. We have loaded all the GIS layers into the predefined geometric network from the UDM version 7.2.1 and solved most possible connectivity errors as per the real ground situations, but we have kept some of the errors without fixing since the geometric network requires SEC review to solve its own built-in errors. However, the whole geometry network connectivity rules needs to be redefined as per the current project requirements. 3.18 Manufacturer Attribution. In common, very few new company names are missing in the manufacturer domain coded values. We are having the required information filled in the respective features comments. Attribute. We can recalculate those manufacturers once the UDM changes implemented. 4. UDM change requirements. As per our review and pilot execution, the SecUDM covers all required feature classes with their subtypes and required attributes. However, we found the following changes are needs to be done in the data model to make it appropriately match with GIS project SO and requirements defined by SEC. Above listed changes are as per the initial review and as per the mandatory attribute list provided by SEC. Please refer to the appendix to mandatory filed _compare _ to _UDM _30 OG 2023.xlsx. MNK may submit further change request based on the pilot data feedback from SEC and also as per the project requirements. As per SEC PMO advice, we have not done any changes to the SecUDM template provided and waiting for SEC technical team to review the changes required and will implement the same.